right, this is MGF 1107, Chapter 8, Geometry. The first section we're going to look at is 8.5, Transformational Geometry, Symmetry, and Tessellations. In this section, we're basically just going to be focusing on the transformational geography and symmetry. The tessellation, if you choose to do the extra credit assignment, then you'll learn about that. So in this section, you'll be learning about transformational geometry and symmetry. We will not be studying tessellations like I just said. Transformational geometry. So the first thing we're going to check out is what is transformational geometry. We will be looking on ways to transform geometrical figures without altering the shape or size of the figure, which is called rigid motions. That's what we're going to start out with. Think of having a two-dimensional figure, picking it up and moving it somewhere else on the plane. This is transformational geometry. You can actually use transformational geography to manipulate three-dimensional figures. So it would be like picking up something off your table and moving it to the couch. That would be an example of transforming a three-dimensional object. So when we talk about two-dimensional figures, we're just going to basically have a figure and we're going to move it someplace else on the plane. An example of a plane is a Cartesian coordinate system, so you can see that right there under that example. So let's go ahead and have the original figure. So let's say this is my figure here, which is a triangle. And for a triangle or any other figures, when we do this, we're going to have points. So we're going to have point A, point B, point C. Okay? So all I'm going to do to that original figure, and let's make it a little fancier, we're going to just move it. So I'm going to draw this figure again, just someplace else, like down here, let's say. And I'm going to draw this in. So my new figure is A prime, B prime, C prime. So once again, when you have the figure that you've translated, and I just highlighted the one that we translated, we use prime symbols, that's the little symbols next to the letter, to show that that's our new figure that we have transformed the old one. Okay, so the next thing we're going to talk about here is reflection. Reflection is a rigid motion that moves a geometrical figure to a new position such that the figure in the new position is a mirror image of the figure in the starting position. In two dimensions, which we're going to be dealing with, the figure and its mirror image are equal distance from the line called the reflection line or the axis of reflection. In these notes, I'm going to be talking about the axis of reflection because I'm going to show you actually two different ways to be able to reflect across the x or the y axis. Okay. So I know you guys have seen this before. This is just a Cartesian coordinate system. This time around we have the x and y axis. So just to highlight that, the x-axis is here and the y-axis is here. Okay, so what we're going to do is I'm just going to show you some examples. So I'm going to erase my highlighted area really quick. So if I want to reflect upon the x-axis or across the x-axis, I'm paying attention to this. So an example of that would be, let's say I have a figure here, and I'm just going to quickly draw it, and I promise you that I will teach you how to do this in a minute. So I'm going to draw a figure here, and it's a rectangle, A, B, C, D, and to reflect it across the x-axis, I'm going to put a point here, I'm going to put a point here, and I'm going to put a point here and here. So this is my new figure, so this would be A prime, B prime, C prime, and D prime. So that's reflection about the x-axis. Notice that A and A prime are equal distance from the x-axis. So that's an example of a rotation about the x-axis. Now let's focus on, and I'll just erase this, the y-axis. So the y-axis is right here. So if I want to reflect upon the y-axis, once again I have some figure. Let me just draw a square. Be fast and easy. So I have square ABCD. And I've reflected across the y-axis. I'm going to put my points here. It's going to look like this. A prime, B prime, D prime, and C prime. So notice that A prime and A, D and D prime, C and C prime, and B prime are equal distance from the y-axis. So that's just a quick example of reflection across an axis. So now we're going to go ahead and do this next bit, construct the reflection of a triangle ABC shown in the figure below about the y-axis, and I'm going to write down the steps to construct the reflection. Okay, so there are two things that we have to know. One, if you have a highlighter, sometimes it's a good idea just to highlight the axis of rotation. So we know that it's telling us to reflect about the y-axis. Okay, we don't have a figure here because I didn't draw it in initially, so I want to draw this in really quickly. So the original figure is going to be a triangle, and the triangle is going to have special coordinate points. So let me be very careful when I draw this. So here's my original figure. This is ABC, so it's triangle ABC. So the original triangle the coordinate points for A are 2, 2. So the x value is 2, the y value is 2. For B, it is 5, 2. And for C, the coordinate point of C is 3, 5. Okay, so make sure you have the same coordinate points for this original triangle. If you have to pause me, that's fine. Just go ahead and do that, and then we're going to pick up again. Okay, so there are two ways to reflect. So here, I'm going to put over here steps to reflect. Okay, the proper way is to find the coordinate points and then change either the x or the y values. So if you are reflecting about the y-axis, then you will change the x values of each coordinate point to the opposite. You will keep the y values the same. Okay, so let's go ahead and do this. If you're reflecting about the y-axis, then you're going to change the x values of each of the coordinate points to the opposite value. You will keep the y values of the coordinate points the same. Okay, so remember their original was point A was 2, 2. So the translated value, or the reflected value, I'm going to keep the y value the same, which is 2, and I'm going to change the x value to the opposite. So positive 2, negative 2 would be its opposite value. Okay? For point B, the original was 5, 2, so the reflected value, or B prime, is going to be negative 5, and I'm going to keep my y value the same, which is 2. And for point C, the original value was 3, 5. So for C prime, I'm going to change the x value to its negative. So if it's positive 3, the opposite would be negative 3, and I'm going to keep that y value the same. So all I have to do now is I have to plot the reflected value points. So I go over here, and I'm going to use a different color. Let me see. Let's use purple. So the new value is going to be negative 2, 2. So I put the dot there. Hopefully you guys can see that. B prime, and let me label that as A prime. B prime is negative 5, 2. So I put the dot there. And C prime is negative 3, 5. So I go to negative 3, and I go up to 5, which is here. And I draw in my figure. So the purple one is the translated value. So this is my answer. Okay. The other way that you could do this is you could literally count the distance from the from the y-axis to the figure and draw it that way. So that's the other method that you could use. So let me go ahead, and I'm going to carefully remove the highlighter, and I'm going to show you how to do that. So if you look here, the distance between the y-axis and point A is 2 units. So when you draw the new one, you go 2 units on the other side of whatever axis you're rotating. Remember, we're doing y-axis. So 2 units away, and I'm going to show you a little line there, and let's do orange. So 2 units away is equal distance on the other side. You see what I mean? And then B is 6 units away, so this whole distance here. So I go 6 units on the other side and draw my point. C is 3 units away from the y-axis, so I go 3 units in the other direction and I make my point. So once again, when you reflect about the axis, the points are equal distance away. So you can either use the steps of reflection I just showed you with keeping the original points, reflecting the values by changing either the x value or the y value, depending on what axis you're rotating about, or you can just count how many units away it is from the axis of rotation. So before we leave this page, I am going to finish out writing the steps of reflection for the x-axis. I know we didn't do this in example, but if you want to reflect about the x-axis, then you will change the y values to the opposite. So you're going to change the coordinates y values to the opposite. And I don't know why I have values twice. So once again, you're going to change the y values to the opposite, and you will leave the x coordinate portion of the points alone. Okay, so if we reflect about the x-axis, x values stay the same, change the y's. If you're reflecting about the y-axis, y values stay the same, change the x's. Okay, so you do the opposite, change the opposite one. Okay, so let's go ahead and see this next one. Construct the reflection of rectangle ABCD shown in the figure below about the x-axis. Okay, so you don't have a figure because, like I said, I didn't put them in. So I'm going to go ahead and draw quickly a rectangle. So first coordinate point is 2, 2. Second coordinate point is 7, 2, and this will be point B. The next coordinate point is point C, so I'm going to make point C 2, 5, and point D will be 7, 5. So let me go ahead and label this C and D, and then all you have to do is draw in the figure. So here is my rectangle ABCD. Okay, so remember, I'm reflecting about the x-axis. So if I'm looking at this, I have the x-axis here. I'm going to reflect about it. So you have two choices. One way is to count how many units away from the x-axis each point is and to draw in the new point. Or you can use a proper way, which is to change the, in this case, keep the x values the same, change the y. So I'm going to keep the x values the same, and I'm going to change the y values of each coordinate point. Okay, so we have A here. The original was 2, 2. I'm going to keep the x value, change the y. So 2, negative 2 to its opposite. B is keep the x value, which is 7, change the y. So this is now negative 2. C, change the y value, keep the x. So 2 is the same, and 5 becomes negative 5. And D, 7, 5, I'm going to keep the x, change the y. Okay, so now I have to draw A prime, B prime, C prime, D prime. Okay, so let's pick a different color. Let's go ahead and use purple. So A prime is going to be negative 2, 2. So I'm going to put a dot there, A prime. B prime is 7, negative 2. And I just made a mistake, guys. Sorry about that. I don't know what I'm thinking. Let me erase that. All right, we reflect about the x-axis. Sorry. So that was not right. So let's look at that again. 2, negative 2. 2, negative 2 is right here. Sorry. That's A prime. B prime is going to be 7, negative 2, which is right here. C prime is 2, negative 5. And finally, D prime is going to be 7, negative 5. So that's points right here. And then we draw this in. So once again, you can use this method. The other method would be is to count how far away point A is from the x-axis and then reflect it across the x-axis by making the new point A prime equal distance away and continuing on with all points. So that's how we reflect about an axis. Okay, I'm going to go into this translation and then we're going to stop and you're going to have another video for this section. So this is translation. The definition of translation or a glide is a rigid motion. So remember, rigid motion means we just pick up the figure and we move it by sliding it along a straight line segment in the plane. The direction and length of the line segment completely determined by the translation. So when we glide a figure, we're going to use what's called a vector. A vector looks like this. It looks like a ray, if you remember that from geometry, but the difference is the with a ray, the second point would extend through. So for instance, I'd have starting point A, and then I would go through B and continue on. With a vector, we have a starting point of A, but it stops at the end of the arrow, which is point B. So vectors have magnitude and direction. Okay, so magnitude means it has length. So we can find out how long the vector is. The directions are going to be in terms of north, south, west, and east. So we can have northwest direction, we could have northeast direction, we could have southeast direction and southwest direction. Okay, so this is, I'm going to stop the video here and we're going to pick up in the next video.